Yes. Okay. Then I'll go back. So the new cotton project then. This is a research program, and over a 3-year period, we collected and sorted post-consumer waste generated into a new cellulosic fiber using Infinite Fiber Company's textile fiber regeneration technology. And as you can see on the picture here, this project actually succeeded in putting commercial products out on the market. The coordinator has been Infinite Fiber Company, and RISE, as part of the consortium, has had the role of assessing the sustainability aspects. That includes life cycle assessment, social life cycle assessment, TA. We also looked into Ecotech's STEP and Made in Green criteria. And the ones that made this happen, I seem to have problem with this. So the project partners are Adidas, Aalto University, Fashion for Good, Innovafil, Keepas, Revolve Waste, Frank Noyes, H&M, Infinite Fiber Company, Textina, SAMK, and Research Institutes of Sweden. That is RISE. And it is a Horizon 2020 framework program. And with this, I will leave the floor to Jutta, who will talk a little bit about life cycle cost, if I'm not wrong. So, Jutta.
Thank you very much, Ann-Charlotte. Yes, life cycle costing, or some people call it life cycle cost assessment and life cycle cost. It's not very clear. It's not very harmonized area of work, even though it's much older than the life cycle assessment that we also work a lot with. So it's an assessment tool to estimate the entire cost of typically large-scale assets with a long serviceable life. And even though it's not harmonized with a general ISO standard, there are lots of rules and regulation in place, especially for special industry sectors. So the transport sector and the construction sector, they often have this as part of the contracts between two partners. And for the textile sector, sort of applications where you can think of using life cycle costing are in textile manufacturing, where you have to buy lots of large-scale machines. Can be a singe, a stentor frame, a dyeing machine, or a washing machine. And you have different. Sorry? Could you mute yourself if, thank you, that are used for very long time. So for this type of object, you often have different options regarding the type of costs that occur. Capital costs are occurring upfront before you even get the machine running, and operating costs, including maintenance, service, and personnel costs, are then running during the operations and for long term. And then you also have the aspect that at the end of the use phase or the end of the life of the machine, there's potential benefits from recycling or impacts for treating of waste to be considered. And that's supposed to be considered by life cycle costing. Next slide, please. Yeah. In the private sector, which would be in the industry sector, including the textile manufacturing industry, there's also another term used, and it's very similar to life cycle costing. So might be a minor difference, but for the purpose of this webinar, we can treat it as if it's equal. And they have this nice iceberg model to show that the purchase costs are often just a very small part of the complete cost. So the hidden cost is estimated to be about 70 to 90% of the total cost for such an investment. And so it's the hidden part of the iceberg. And the hidden part can include the installation and delivery cost, the labor cost and workforce cost, education and training for those who work with the machine, unplanned downtime, which is a very big part, especially if the machine that you are thinking about in industry can be a bottleneck. The risk management and safety, warranty cost for scrap and waste that are occurring during the operation, and cost of the fuel and consumables and parts that are needed to operate this machine, and maintenance. There might be more, and this is in no particular order. So the total cost of ownership is often the term used in the private sector. And applications to calculate total cost of ownership or life cycle costing is when you have different machine options with a similar capacity, but with different peripheral equipment and different purchase cost, or even with different flexibility and upgradability. Then a TCO is a very relevant tool to consider which machine you should use. Next slide, please. Another option in especially related to the textile sector is something that's really now related to public procurement. And the EU has this strategy in place for sustainable and circular textiles. In the annex, it is announced that in 2024, so this year, there will be published mandatory requirements concerning green public procurement and member state incentives. These are related to textile products. So it's not the manufacturer's perspective, but it's the user perspective in green public procurement. There is a Commission staff working document available online from 2017. It's not updated since then, and it feels a bit outdated, so something might happen. It's announced that something might happen there. And this staff working document includes one section on the estimation of costs for textile products for public organizations, for workwear, for instance, for police, army, or hospital, public sector incentives or initiatives, and for equipments such as towels and bed sheets. Next slide, please. So in this case, you don't look at the at large scale investment in one machine, but you look into buying lots and lots of equipment for the public sector. And this staff working document contains 3 hints, or contains also a lot more information. But what they refer to is that you have to think about laundering, where the fiber composition has an impact on the amount of energy that is required to wash, dry, and iron them. Think about the lifespan, where the resistance to wear during use and laundry cycles is strongly influenced by fiber composition. And the design should be made to increase the use phase from 2 to 3 years. And about the end of life, the disposal of textiles at the end of their useful life is a cost burden for public authorities who will have to pay by weight. This is, as I said, from 2017. And one of their conclusions is actually that instead of going for 100% cotton products to use cotton, polycotton, so cotton polyester blends to increase the lifespan, but that obviously comes with some also benefits or not benefits for the end of life. And next slide, please. Now back to the life cycle costing usage. So the results of the conventional life cycle costing can be used as a key indicator in tenders, in common practice in several industrial sectors, such as the transport sector, for long living goods, and it's also notably used in public procurement. That's where the tenders often are mandatory. The procedures include regulation for validation and quality assurance, for data collections and for identifying of unknown and uncertain information, such as future energy prices, because a lot of the information is not fully decided, especially for this long-term use. Next slide, please. I mentioned that on the slide before that this was the conventional LCC, and there are different types of LCC. It's not really fully regulated, and there are options to do it in different ways. So if you do an LCC and with the intention to combine it with a life cycle assessment, the environmental part, and especially also if you then want to add a social LCA and do a life cycle sustainability assessment with a very aligned way of approaching it, you can have benefits if the LCA and LCC are conducted in parallel. The processes that you base your calculations on are often identical for LCA and LCC and can be based on the same inventory model, which is a positive and efficiency gain. So in LCA, you follow up the flows to identify the elementary flows from and to the ecosphere. And in LCC, you use the same flows, but follow up to calculate costs and revenues for the very same product, align it. But for LCC, you also need costs that are not related to flows, not related to resource use, and are not immediately related to a physical flow. They accrue during the time period for producing a functional unit, for example, insurance or interest rates for capital equipment. These costs are there without producing anything at all. Next slide, please. Several aspects are different for LCC compared to LCA, and one of them is including that you consider a time frame and discounting. That's not something that you do in LCA. Future emissions are as relevant as today's emissions, and that's different in LCC. And in LCC, you have assessment perspectives. So I mentioned the textile manufacturer. It's their perspective and their cost and also their revenues that are considered in an LCC for a textile finishing machine. And the public procurement, where you have the army or the police force or a hospital who does the assessment. And it's in that case, it's their cost and revenues for different options. LCC summarizes all costs associated with the life cycle of a product that are directly covered by one or more of the actors in the product life cycle. So it has to some extent an internalization also of external costs, but it's not a societal LCC. That would be another option. As I said, it's not so well standardized compared to an LCA. Next slide, please. The intermediate results of modeling are then and life cycle inventory. These are used as an estimation of material and energy flows for production process or product system as a basis for this evaluation. And you add the period-fixed, period-oriented costs for personnel and the investment costs. So these are the fixed costs that are added, and examples for that are the depreciation for the machine, running the machine, the interest costs for the capital, insurance, maintenance, and license fee. There might be more. So this is just an example, and you can obviously find more for specific cases. Next slide, please. If you use an LCC to compare different investment options, machine A and machine B, and machine B has other properties, the easiest way and the most established way for LCC is not using dynamic modeling, but it's application of a static approaches, such as the cost comparison method and the payback period method, to understand whether an investment is beneficial in the long run. The duration of the use and the depreciation are estimated based on knowledge and based on previous experience. It's often calculated with a linear depreciation, so no exponential things are going on here for the entire duration of use as the more regular option. And the interest is calculated based on tied up capital. So the interest actually also decreases over time as you pay back to the banks. There's the cost for maintenance, insurance, and taxes. They're also estimated for the capital expenditure, so they are higher if for a more expensive buy. Next, please. Purchase. And this is an example calculation, and we have tried to find more examples also related to textile industries, but this is often handled between two parties, and it's the results and the approach is a bit confidential, or it's, let's say, it's very confidential, because it also sort of discloses business relevant information. If your business partner knows exactly what are your costs, then they also can understand what is your winning margin in a project, and that's not something that that you want to reveal, even in a very open consortium and a very open relationship between customer and client. This is something that's not very often disclosed. So you can, based on this, is a combined heat and power plant that's is for public sector, where they have some information disclosed, and also it's based on estimations. There's the purchase cost for the equipment, and on the left side, there's also the fuel substrate cost for running this, operating this machine, combined heat and power. It's quite a big thing. It's 727,000 euros. So it's a total purchase cost is quite high. And then you also have the reimbursement costs for the electricity and heat that's produced from this machine. So if you use all this information and then make a 20-year calculation with estimations on the hours of operations, and assume what is the reimbursement for the different types of products that you can sell from this. And in red is always cost, negative costs. So these are costs, whereas in black, these are the reimbursements. So the costs for the substrate are a bit different over the years, and then you need some general overhauls every now and then to make the machine last longer, and you have the regular maintenance cost each and every year or regularly. And then you can calculate what's the present value of this machine. So in the first year, when the purchasing costs are arriving at full scale, it's the purchase cost, but over the years you can see that the present value for the owner of the machine, for the operator of the machine, decreases. And but it's at least it's black, so it has a positive present value, and the net present value is actually quite nice. So this could be also used in decision making whether to purchase such a combined heat and power plant or not. Next slide, please. The data requirements, I think that this is an important part when thinking about whether you can do an LCC, whether it's possible and meaningful to do an LCC. It's suitable for projects where you have a high share of available data, and that is often related to a high TRL. So for machines and equipment that are already available and have to be tweaked and twisted. And the results are often treated as confidential. So you will not find a lot of public LCC results out there. And when you have a low TRL, when you have innovative developments, and that's obviously something that is very relevant also in the textile sectors, apart from the two examples that I had based this on, the manufacturing machine equipment and the public purchasing. But when you have a low TRL, for instance, for new fiber development, there might be other tools available. And Pietro is going to speak about one option, the TEA, from now on. Thank you.
Thank you, Jutta. Next slide, please. So I'm Dr. Pietro Bertocci from Rice Processum, based in Örnsköldsvik, Sweden. And our key research activity in our institute is biorefineries. So I will present applications of techno-economic analysis for biorefinery products which can be applied in the textile sector. This product development in our group, which is the System Innovations Group, is based on the stage gate process. So we have an idea, conceptual development, testing and validation, and the launch of the new product, which could be, for example, as Jutta said, a new textile fiber. We see that in the different stages we have a different detail of the analysis. The analysis has 6 steps when the idea is development, while the steps increase to 11 after the conceptual development and before testing and validation. Techno-economic analysis can be placed between the technical assessment and the business case, because next slide, please. Because techno-economic analysis has an important part on cost estimation, while a complete business model is a more, as we'll discuss further, is a more complete kind of analysis, while here we focused mostly on the costs. Techno-economic analysis as LCC is not standardized by ISO norms. So I choose for this presentation to use the guidelines of the National Energy Technology Laboratory in the US that foresee 4 steps for techno-economic analysis, which are development of a technology analysis plan. This part is a roadmap for our analysis, is discussed with the project owner. It has already a process flow diagram inside it, and it has already an idea of what is the current technology, so the business as usual technology, and what is the new technology we want to analyze. The new technology is an important part because, as Jutta already said, while LCC is for high TRL product, techno-economic analysis refers more to products that are under development. The creation of a performance model is usually done with the software, which could be, for example, Aspen Plus or Unisim, to model mass and energy balance of the process. From these mass and energy balances, we can infer variable costs, and with different method or capital costs to have a clear idea, a clear picture of all the costs. Next slide, please. So when to use techno-economic analysis? When we need to evaluate investment. Investment could be on a new product which is produced on a new plant, for example, but investment can be also in R&D. There are many industrial sectors in which the R&D investment is a big part of their business. So, for example, if we have different technologies to produce the same product, we can evaluate them against what there is in the market also, to see where to put more focus in our company, which technology we have to use and to develop more to go on the market and be competitive. Data gaps, for example, if we have a catalyst in our research and development phase, which is important for our product, but we don't know the costs, this can be used to evaluate the cost of the single materials that affect in the end the economic viability of our production line. Next slide, please. So the difference between a techno-economic analysis and LCC is that with the techno-economic analysis, we compare the different technologies, mainly based on products of the production phase, while on the LCC, we based on different phases of the life, like development, producing, using, disposing of an object. So we have more wide cost expenses respect to technical economic analysis, and we have also a relevant information on the impact on the environment in the second case. Next slide, please. The benefits are for decision making, especially as we said in the case of investment, and for technologies with the low TRL level, so products that are under the research and development phase. Next slide, please. Limitation is that this is certainly an economic analysis, but it's an ex ante economic analysis. So we are evaluating an investment that will be performed in the future, but we are evaluating this investment with the current costs. This means that this kind of analysis has no cash flow projections, no discounting, and also we evaluate only the costs and not the revenues, usually. Is not a standardized technique, does not evaluate costs available through the whole life cycle, but only costs that are available during the production phase, as already said. And we cannot infer almost anything on the environmental impact. Next slide, please. So as a case study, we decided to present the production of 1,3-propane diol. Why we choose this compound? Because it is already produced at an industrial scale in DuPont, by the DuPont company. It is also a compound which is a precursor for nylon and polyester. So in the world of the fibers, we place on the biosynthetic fibers. And it's quite an old case study, but it has general information which are not linked to industrial data. So it's a published work and it's not confidential data. Next slide, please. For the production of this molecule, we first take into account what is the what we called the process development phase in the techno-economic analysis. And we see that this is a biotech process with sugar as an input. In our biorefinery cluster, for example, we use sugar from forestry materials. And it's based on fermentation and downstream processing that are used to separate the useful product from all the unwanted substances, which can be microbia or side products that are not the mainstream product. And this product can be used to, this process can be used to produce propanediol, but also many other products. So biotech industry has many types of applications. Next slide, please. For this process, we it was studied in the literature. The variable costs, the fixed cost, mainly inside battery and outside battery costs. And what is more interesting is that it was assigned a capital charge of 30% calculated on the total fixed cost. This means that the capital charge is the cash flow required to compensate investor from the fixed costs. So in our techno-economic analysis, the final parameter we use to compare our product with the current market products is the production cost plus profits, which is the sum of the variable costs, taxes, marketing, administration, and research and development expenses, plus the capital charge. So in our final indicator, the fixed costs are not taken into consideration, or they are taken into consideration indirectly because they affect only the capital charge. This was the useful parameter to compare the performance of the precursor for textile fiber against what is the fossil market competitors. Next slide, please. What it was done, it's to calculate fixed cost for 4 scenarios. These are 4 types of process we can use. In the first scenario, we assumed that the biotech technology was performed in batch mode with distillation as a downstream process. In the second route, we assumed that the technology was produced in a continuous way with distillation, and so on, more and more advanced technology for downstream processing. This has to be understood as a learning curve for the technology. So basically, shifting to the right, we have more efficient processes and less costs in general. Next slide, please. So this is what is shown also in the final results of the analysis, in which we see that to the left we have the industry average production costs plus profit. The industry average refers to the current processes available in the industry, which are DuPont or natural work processes. And these data were basically used to calibrate the model. While the model which was developed by Utrecht University. This is the first route of batch biotech process and distillation. Then we have continuous distillation, and the costs are sinking. And we see there is a general decrease of the cost while we shift to better technologies. And this was the fossil competitor, and we see that in the future this technology could be much more convenient than the fossil competitor. This is also confirmed by the fact that the product is already commercial. That's it from my side. I pass to the next presenter.
Okay, good afternoon from my side, from Espoo. My name is Riikka Vandenkoor, and I come from a company called Infinite Fiber Company. So in case some of you are not familiar with our company, so we have created a technology with which you can turn textile waste into new cotton-like fiber. And we have a plan to commercialize or build the first commercial scale factory in Finland for annual 30K ton production. So maybe you can move to the next slide. So as this information that is used in techno-economic analysis is confidential, company confidential, I won't be able to share any numbers or findings of our calculations, and the material that is also reported in the report for this new cotton project, they are only, let's say, indicative numbers and not what we actually have put in together because of the sensitivity of the information. And therefore, I would like to have just discuss maybe more how we have used as a company this techno-economic analysis as a tool to plan our operations and communicate our story to investors. So our initial analysis was done somewhere late 2020, early 21, when our technology were at that stage that we would be able to start considering scaling it up or commercializing it. And that was a large activity that included very thorough analysis of the market potential for the fiber, also getting an understanding of the value chain from, let's say, from the textile waste or the raw material into the actual clothing. So where would our company be? So is our offering technology, or do we want to actually produce the fiber ourselves? And we decided to go for the production of the fiber because this is a process industry technology. So you need to learn also from the running of the process. And also there was studies made on the availability of the raw materials, so namely textile waste, but then also other chemicals and utilities, green energy, and so on, all the things that are needed for us to run the process. And then there was also considerations of the site where we would build the factory, so whether it's a greenfield or a brownfield, and all this information was then put into, at the end, also into a very complex calculation, so which has been then used to tell our story to investors, because at the end of the day, what they are looking at is the numbers and not the stories and slides. And since we have this is new technology and something that hasn't been done before, there's clearly a lot of uncertainties. And I think this process, the whole process of making this kind of techno-economic analysis has helped us to also understand those uncertainties. So first of all, we have a new technology, that there's always risk to developing a new technology. We want to run that technology for the first time in a real commercial scale factory. There's some uncertainty to that one. And then we have actual end product, the actual Infina fiber, which is also new to the market. So there's a lot of things that we don't have a reference point to, really, that doesn't exist. But then going through this analysis, of course, you are able to identify things that are maybe predictable, where you can kind of foresee how things will develop. So, for instance, and even there, you might come across with uncertainties or surprises. So, let's say price of chemicals or price of energy has been fairly stable for years, and then in 22, when the Ukraine war started, things didn't were not stable anymore, but they did peak. So in a way, it has created a lot of awareness within our company, though, that you need to take a lot of things into account and then also try to find ways to mitigate those risks. And as such, I would say that this analysis was at that time one big effort, but it's something that we continuously keep running in our company, to understand that the decisions and the direction that we have taken is the right one. and also it has given us a tool and also competencies to start kind of also evaluate alternatives. So to verify that the decision to build our own factory is the right one, but then also always keep in mind that there are alternatives, because we need to be also maybe honest in this one, that maybe not all things have progressed as fast as we thought back in 2021, partially because of the financial or economic change in the economic environment. And then this kind of approach also helps us within kind of like when we develop the technology and becomes kind of more clear that, or we do make progresses, so we can always also analyze like those technology solutions, that what is the best one, what is the most efficient, and which one is the best also from a, let's say, profitability perspective. And this whole way of thinking and looking at data have, of course, increased a lot competence and awareness within our company of different aspects that relate to creating new technology and commercializing it, and putting this all together into numbers, something that Pietro was actually showing. We have done also helps us to communicate our story to the investors with the backed up with some facts, so not just telling some, putting together some nice slides, but actually show in numbers that we have a viable business case. Thank you.
Ann-Charlotte, you're muted.
Thank you. So now we actually have a few minutes over for any questions, if there are any. Not that I see here. I have a question for Rika. What about sensitivity analysis? Have you done that within the TA scope, so to speak?
Yeah, so that has been part of it. So kind of understanding what are the sensitive, or what are the areas that have the most impact on our business case. So yes.
And I have a question for Jutta. Sensitivity analysis within the LCC, is that something that you do as well?
Yes, it's actually it's as I said, there are many ways to do LCCs, and in the contracts, when it's required to do an LCC to get awarded a contract with a big public industry or big public authority, it's necessary to provide evidence and to provide also sensitivity analysis, especially for the energy prices. That has been part of these contracts already since a long time ago, and it's probably even more important nowadays. Yeah, so this is done, yes.
Yes. Okay, any last remarks from Pietro or Jutta?
I can probably add also, I would like to add that this can even be written in the contracts that those who offer a machine or a new equipment have to pay penalties if they underestimate future costs. So if somebody comes up with very unrealistic projections for the future and then they cannot keep it up, then they get a bit of a punishment for that. So it's really part of contracts in some industries.
Now we have a question in the chat. I understand LCC is more suited for high TRL technology. However, do you see any advantage of using LCC in an early stage technology?
Right. I think that that TA is the more suitable context, or more suitable method in that case. However, if you want to go for the full life cycle, and if you want to also include, for instance, circular approaches such as reuse of a machine after the first use phase and this type of application, then a full life cycle definitely has some advantages. But of course, because it's a high uncertainty at an early stage development, the results might not be, the quantitative results might not be telling so much, but as Rika said, you get a better understanding about the relations between investments and revenues. So it could be useful in a not very quantitative way, to put it like that.
We have another question for you, Jutta. What do you suggest to do if there are some real costs are missing when developing LCC analysis? Lack of data, I suppose it's in that area the question.
Yes, I think it's interesting to look then into tools that are published also by the EU, what is done there. So it's obviously not a very good choice to leave them out. You could maybe do some scenarios where you say about include some worst case assumptions and make it really expensive. That could be a way to start it off, and not so Deutsche Bahn actually has this approach. I say if people underestimate costs in their proposals, then it's their fault if they cannot keep the timeline, cannot keep the costs. So this would be a way to provide incentives to rather overestimate costs, even if you are in a competitive situation when you submit an application to a tender.
Yeah. Okay. I can assume that lack of data can be a problem for either of these tools. How easy is it or difficult is it to get specific data? I know we're talking about generic data versus specific data.
Is this for me?
Pietro is still muted, so.
Sorry. Yes, maybe we can give some advice on where to find costs. Maybe there are very nice cost analysis which can be accessed by companies. For example, on I think S&P 500 website, there are some market analysis on, for example, these bio-based products. And other costs, the tool that I mentioned, Aspen Plus, at least for process and product development, as one of the best cost database for different plant equipments and utilities. And another aspect is market analysis of different inputs that we insert in our process or product.
I just got a question here. Can you write these database down in the chat so we know exactly which they are, or perhaps a link? Could be good.
And when it comes to primary data, I think it's also often you need to come to a mutual trust. So if I ask for data and then I have to understand that this is, if it's done for a certain perspective, then I cannot share that with competitors, and I cannot share that also along the supply chain. So if I get data from the textile manufacturer, I cannot share that with the the brands who buy from this manufacturer, because it can reveal not only what the costs are, but then also what's the margin of income is for this certain manufacturer. And we don't really want that to be it's not supposed to be used in negotiation. I fully understand that Rika has to keep a close lid on all the results, because it can tell a lot more to those who buy from her.
Yeah.
And
Diego
had a question about
I'm
the
starting
currency.
a meeting.
No, no worries.
No.
I'm going to the other room.
No, you don't have to, because I'm just listening to a
okay.
webinar.
Now
Okay.
No,
some people are
I
not
don't.
muted.
I don't need to. I don't need to. I can go to the control room.
Okay, Diego had a question, Jutta.
Yeah, and Diego had a question. It's about the currency exchange. And I
do you want me to? Yes, I can just tell you. I think I was thinking that maybe when you need to, because if you are going to use data from if you have global supply chains, and then you're going to get data from different databases, and you're probably going to get data in different currencies, and then you need to probably convert to a single one, and then you need exchange rates, and they fluctuate over time. So I don't know if you have any tips for us how to handle this high uncertainty and volatility.
I don't.
Yeah.
I guess the using US dollars or maybe also euros, a more stable
I think most
currencies.
of the purchases, or most of the, at least for us, the chemicals and so on, they are in currency stuff that are fairly stable. So the fluctuations, I would say, come from the interest rates if you start more than in the currencies.
Interesting.
Yeah.
Thank you.
And if let's say there's a peak in a strong currency, let's say, or common currency like euro or USD, then there probably relates to some other macroeconomic change as well, which will also impact the interest rate. So it's like a hiccup in the whole system then. So.
And the ones looking into the chat can see that Pietro also put another link in there. Okay, I will stop the recording now. I'll try at least. Oh.